First, let me thank you guys for making time today. This is a great event for us, and I hope you guys are getting a lot of value out of everything that you've learned, both on the Gov Forum and on the Tech Day. We're going to talk exclusively about cybersecurity. If you don't have interest in cybersecurity, I'd be really interested to talk to you about why, because you should. I've been doing cybersecurity for over 20 years. I've done it at the government level. I helped with right across the street with DOJ JSOC for a while, helped lead their analytic capability there. I did it for the Air Force. I've run managed security services back when EDS was a thing many, many years ago. And I've, of course, worked on some vendors like ArcSight and RSA and things like that, running analytics strategy for RSA. This is pretty much all I know, is cybersecurity analytics, detection, incident response, that sort of capability. And Morris and I worked together at ArcSight a decade ago, so we've got a long history of helping organizations understand what visibility means and how to detect threats faster. And over that time, things have gotten harder. There's a lot more data to deal with. Right, when I first started my career, the tools were SEDOC and grep, and that's what you use to go through to do analysis. Today, cybersecurity analysts need access to log information, network information, endpoint, memory, artifacts like PDFs and executables, threat intelligence. There's a ton of information, and we're asking them to be data scientists and the ability to reverse engineer. There's just so many capabilities we're asking of our teams that it's important to have all the right tools and all the right data in one place. One of the most important things that we're doing here with this approach in this conversation is helping everybody understand there's a better way than the way we've been doing it for the last decade. For the last decade, we've been sharing IPs and domains and hashes and PDF files back and forth and calling that information sharing and threat intelligence, and that's insane. What we're talking about is let's share analytic models. Let's share machine learning amongst organizations so everybody can raise the bar, not just with a single point in time threat, but with an entire maturing the capability standpoint. So that's what we're going to talk about today. So the world today and the world where we're headed is not measured in millions of events per second or millions of events per day anymore. It's more in the millions of events per second. Right? Back in 2002, 2004, when I was with ArcSight, those SIM tools were built, all of them, to handle maybe a couple of million events per day. Now we're actually talking about designing systems that can handle multiple millions of events per second, moving towards 1 trillion events per day, being sourced by a lot of different things, right? Not just traditional enterprise security tools that we'll talk about in a minute, but everything is instrumented. Software-defined networking, software-defined CPU, everything that is generating data and generating instrumentation data can benefit cybersecurity analytics. Our tools need to be able to keep up with the ingest, storage, processing, analytics, and data representation of all of that data so that our analysts have enough data to understand the threat and the impact of what they're dealing with. There's some, I guess, globally applicable challenges that we see in the industry. The explosion of data that I've talked about. There is a ton of data. It's not going anywhere. I was asked earlier today by a member of the press if this is going to go away, and I'm like, no, it's going to get a lot worse. There's going to be a lot more data for our analysts to deal with. And that's a good thing. The analysts, the more data they have, the more context they have, the quicker they can identify the threat, the quicker they can reduce the impact. We can lower the risk. But that comes at a cost. We have to be able to process that information. And we have to be able to keep pace with technology, not revert on technology that's 10 years old. Right? We can't go back and say 1 billion events into my SIM every day and expect it to do something meaningful, not at a cost-effective point. Because those tools weren't designed to handle the amount of data, it leaves us with a gap in visibility. there's a lot of information that's simply ignored. It can't be put into the system either technically or because of cost reasons. So we wind up with a lot of records, whether they're DNS or proxy or NetFlow or artifacts that are not structured data, that are either highly unstructured or binary, that analysts need that reside in other systems. And analysts wind up bouncing between systems to go get all of the information they need. We're talking about, with this solution and the approach we're talking about, is bringing all that together. And of course, the tools that they use today have very limited analytic capability. If I want to find a known threat using structured data, I can do that very well in a SIEM. And there's a lot of good use cases for that information. But there's a lot more types of analytics that I may want to run that aren't based on finding a known threat on known data. It may be new data sources that I want to learn how to analyze, new analytic techniques like machine learning that I want to apply. Could be new threats that I want to go figure out how to hunt. I need more flexibility in the types of data and the analytics behind it. So this is what we're talking about then, Apache Spot. We call it a community-based approach to fighting cyber threats, and that community applies in a couple different areas. First is the community to build it. You have a community of vendors and organizations that contribute code and resources to Apache Spot, listed on the slides here. Organizations that are expert in technologies from the network, the endpoint, the user, from analytics, security in general, contributing to an open source project to benefit everybody that participates. That's important. It's not just Cloudera saying, hey, we have a security tool. This is a bunch of vendors working together to say this is a new way to work with security information that's going to benefit the entire community. And the second definition of community is, of course, the users that are benefiting from it. Those users that are interacting with the data that exists, the analytics that exist, and pushing them further. Defining the analytics, pushing the machine learning, sharing all of that back to the community so everybody can benefit. So that we're not keeping the same approach, which is every organization defending themselves and ignoring everybody else. Trying to bring everybody fighting together to move forward. Some of the main goals here with this solution, things that I've been focused on for many, many years when I give talks like this, is to reduce risk. We need faster time to incident investigation and response. Right? There are a couple of things you want to measure in any security operations center: time to detect, time to respond, and impact. And if I can lower time to detect and time to respond, I'm lowering the impact. If I can even understand how long it takes, I can measure maturity. And if I can show increases in detection time or response time, I can show that I'm maturing. I can instrument new use cases. I can show that I'm maturing and gaining a better way to reduce risk and improve security across my enterprise. Giving you one place to have all of your information, giving you complete enterprise visibility for the first time so that you're not bouncing between systems, and something that can handle all of the scale. And in a product that can handle multiple analytic engines placed on top of the data that's stored, and I'll talk about that in a moment. Detect faster with machine learning, detect faster with advanced analytic techniques. It can be from COTS solution, from open source, or custom developed. And of course, changing the economics of cybersecurity. Cybersecurity used to be just siloed information, right? Every time we wanted to do a different type of analytic, we would buy another product. And we'd have a project to implement that product. So if I wanted to do user behavior analytics, I'd go buy that product, I'd plug it in, and it would run in its own silo of information. If I wanted to run fraud analytics, it would run in its silo of information. An approach like this breaks that all apart and says we have one platform. We can run many analytics, across multiple use cases, across the entire agency or line of business or multiple lines of business. We can secure that information and we can deliver it to meet the needs of any of those user bases. Data from any source. So in most major organizations, you're going to see a lot of instrumentation, a lot of devices that generate information that analysts may benefit from. This is an example of the security products that exist in the marketplace today, right? You may have a dozen, you may have hundreds of these working across your enterprise. In a lot of organizations, we actually see hundreds of different security tools being in place in different parts of that organization. Not all of that information is fed back to the SIM. In a lot of cases, because it's too hard or it's too costly. We want to be able to deliver to the market a way to handle any type of information in an easy format. So the goal here was, as part of Apache Spot being delivered to the community, was to define these things called open data models. We worked with many of those vendors I referred to earlier to define open data models around network, endpoint, and user. So describing systems, describing users, describing the network itself, take those data sources and apply a normalization, a schema to all of that information that can be written to or read from, and have applications use that information for cybersecurity, fraud, user experience, IT optimization, any number of use cases, starting with cybersecurity, obviously, because that's what we're talking about today, and give you an output to all of that information, applications that can be written and utilized easily. The first application we'll talk about is Apache Spot. There's also vendors that can write our applications against these open data models. So you can plug in commercial off-the-shelf tools, you can use open source, you can write your own to meet the edge cases in your own agency. You can run all three on the same platform concurrently. Really the big benefit here is you can mix and match, right? And I can rip and replace tools that may not meet my need anymore and not lose my data. Previously, if I had a SIM, right, and I had a SIM for 3 years, and I wanted to change from one SIM to another SIM, I'm probably going to lose 3 years worth of data. Or at best, 3 years of data is going to be in that old SIM's format on tape. Completely useless. What we're talking about here is a platform that can take many years worth of data, keep it accessible and available to analytics at all times, change applications as you need to, and not lose the underpinning data because it's all stored in a rational format. So I already talked through this slide basically with that comment, but here's some examples of those vendors. So packaged commercial off-the-shelf tools like Arcadia Data, which we'll show you in a demo in just a few moments. UBA tools, user behavior analytic tools like Secure Onyx, or analytic tools, machine learning analytic tools like Context Relevant, can leverage open data models and deliver you a full stack application around cybersecurity. So there's a discrete set of use cases that they solve for. Great, right? They're gonna write on top of our platform to solve those. You're gonna have a set of use cases that can maybe be solved by open source. We can run those concurrently. Things like Apache Spot, which you'll see in more depth in a few moments. And then custom, right? I have a data science team, or I have a team of analysts that want to hunt, or I have just special needs. I can use tools like Python if I'm a data scientist or whatever else to access the information. I can write an application against the open data model. I can benefit in all of these areas off of one platform without replicating the data. I don't have to create multiple data stores. So how does this look in the real world, right? How am I going to work alongside my existing security tools? So in most organizations today, you're going to have a SIM of some sorts. That SIM can be ArcSight, it can be Splunk, it doesn't really matter who it is, it's performing its functions. Our idea here is let them handle the structured data known threat identification, and let's move the higher work use cases off to Hadoop. And let's benefit from the power of Hadoop to do at scale analytics. And we're going to put this stuff in the Cybersecurity Data Hub using Kafka, Flume, or in a partner world, StreamSets, to ingest the information into HDFS, HBase, Kudu, and then we're going to process that information using Spark, Impala, or Solar through applications, right? Whether it's those independently or through commercial off-the-shelf or open source applications. We're going to benefit from all the data sources, those hundreds of different tools that exist in your environment. We're going to rationalize that all of the information into network user endpoint or threat intelligence to provide you context of all that information together so that these applications can work alongside this. We're not suggesting you replace your SIEM. We're saying that there are use cases your SIEM are good at. Let's do that. There's use cases where your SIEM's not designed to handle. Well, let's move that workload over. And let's work together to optimize your infrastructure to give you the best benefit and give your analysts the most power they can get with all the data available. Analytics at scale through projects you may be aware of or you should be aware of. For search, things like Solar, visualizations, and SQL access into the information with Impala, and then advanced analytics like machine learning using Spark. And I'm sure there's been sessions on this stuff. You guys have probably driven deep into each of these areas, so I won't focus on them today. So with that, I want to hand it over to Morris to let him walk through how one of our partners built a UI around Apache Spot. We'll show you with real-world use cases here how that benefits you.
Hey, good afternoon. Can everybody hear me all right? Good, excellent. So my name is Morris Hicks. I'm a committer on the Apache Spot project. I've been at Cloudera for about 2.5 years. Similar to Rocky, I spent most of my career in cybersecurity working for a couple different technology and services companies since the late 90s. We're going to walk you through a demo of Apache Spot. So let me go ahead and transition to that. All right, so the first thing you should be aware of as we're going through this demo is that the UI, the visualization that you're seeing here, was built by a partner of Cloudera's called Arcadia Data. Arcadia Data is a member of the Apache Spot community. The UI that you're going to see today, they've donated to the community. They've got a freemium version of their product that anybody can download and run, and you can benefit from this UI. Obviously, they have an enterprise, version of their product as well, which drives the financials of their business. But anyway, just wanted to make sure you're aware of that. There are other capabilities that you could plug on top of Apache Spot to have similar, visualizations. Arcadia is by far the best that we've worked with, that I've experienced firsthand. But anyway, just be aware of that. So let's go ahead and get started here. So what we're looking at now is the executive summary page of our executive summary dashboard. And what you're seeing is the listing of top threats across some of the key dimensions within the Apache Spot open data model. So you can see the top user-based threats, the top endpoint-based threats, and the top threats that we've identified from network activity. To help you understand where we're going in the Spot community, we are evolving this to truly be an executive level summary. So we're in the process of mapping these threats to the overarching business processes and governing regulations so that you truly an executive could look at this and have an understanding of how these threats could impact their business or organization. Again, we're not there yet. We're rapidly evolving there, but I thought it was important to share where we're going, because ultimately that's our vision and that's what we're striving for. So for now, you see these top threats across these couple of these key dimensions. Rocky had talked about the open data models previously. So what we've done is we've defined a taxonomy for describing all your cybersecurity telemetry data, and we've defined the underlying storage structures within the Cloudera Hadoop framework components. And then lastly, we've defined the relationships amongst the different types of data so that you get this uber enriched view of the data as you're analyzing threats. You could take advantage of this context when you're building new models so that ultimately we can analyze events faster, we can build more accurate threat detection models because we've got more context within our data set. To give you a little bit better understanding of what I'm talking about, we've got instrumentation throughout our networks, intrusion detection systems, firewalls, we got routers that generate net flow, we've got operating system events, right? MHIX logs into SSHD from this IP address at this time. That's an observation, right? I call that an observation. So we have, within our open data models, there's an object that corresponds to storing all these observations. Well, that observation references a number of entities, right? It referenced MHIX. So there's an entity, a user entity, where we store user information. It referenced the IP address that MHIX logged in from, right? So there's an endpoint entity where we store endpoint information. It also referenced the IP address that I logged into, right? If you think about it, we've got these observations, right? We've got user entities, we've got endpoint entities, there are network entities, file, certificate, all these different objects, right? What the open data models do is they've defined the relationships amongst the observations and all these different entities so that we can bring it all together in a single view, and you could leverage all that context in your analysis. The other important fact of the open data model is because Apache Spot is built on the same structure, any visualizations we build, any machine learning models, any ingest pipelines, everything's portable to other Spot instances, right? Because it's all sitting on the same foundation, the same structure. That's how we're scaling out the Spot community, and that's really what facilitates the sharing of content and so forth. Right? So what we're going to do in the rest of this demo is we're just going to drill down and look at threats across a couple of the key dimensions that are defined within our open data model. So we'll start by looking at threats that we've identified from network activity. In the top of the screen, you'll see that typical count of events over time that you've probably seen in every security technology that's been released to the public over the last 20 years. Same thing on the far right, the network graph, where we've got the different nodes. The size of the nodes is relative to the number of communications or events associated with them. Again, typical stuff that you've seen lots of times. But what I would like to call your attention to is this widget, top suspicious flows from machine learning. So with Apache Spot, we provide a machine learning model that analyzes net flow data, it analyzes blue coat proxy events, and it analyzes DNS queries, right? By applying a machine learning model called LDA, latent Dirichlet allocation. What the LDA model does is it calculates the probability of each individual event based on a baseline of previous activity. So the events that have the lowest probability of occurring are the ones that we deem most likely indicative of a threat. So we do that on NetFlow, proxy, and DNS. If there's any cybersecurity folks in the audience, I'm sure you know DNS is the most abused protocol on the planet. Not the countless denial of service vulnerabilities that it's exposed to, but it's used for command and control communications. It's used for data exfiltration. Right? I just embed the data that I'm trying to slowly exfiltrate into basically the body of the DNS query. So the ability to analyze NetFlow and DNS, of which we're talking about tens and tens and tens of billions of records per day, and uncover the couple dozen that are most likely indicative of threats is pretty powerful. We're not aware of other capabilities that are able to do that at scale, cost effectively. So we're super excited about this. So let's look at this first event here. We've got a source IP, communicating to some destination IP. We see the protocol is UDP. We've got about 20 megabytes of data that was transferred. If I look at the timestamp, it was 31 minutes after midnight. So I need to drill down on this a little bit and look at some of the details in a little more in depth. So if I look at this further, I can see that it was port 119, which is network news transfer protocol. So if I add all this stuff up, I got 20 megs of data transferred at a non-business hour via some port and protocol combination that nobody uses anymore, all from a NetFlow record. So the ML did its job of servicing up a potentially, malicious or threat indicative event. Without the machine learning, there's no way I'd ever get to this point, because I'm talking about 40 plus billion NetFlow records that were analyzed here to identify this one as the most likely being a threat. Right? Nobody can look at that. You need more scalable, flexible analytics to be able to apply to the data set here. So now that we've uncovered a potential threat with our ML, the next question I'm going to ask is, what other data do I have at my disposal that tells me what was going on, at the time of this suspicious NetFlow connection? So you'll notice I did a drill down, and I'm basically saying, hey, show me everything else from this IP address a couple hours before and after this particular suspicious event was identified. If anybody, everybody I've ever met that uses Splunk loves Splunk. They hate paying for it, but they kind of like using it. Well, that's what we've tried to take account into building Apache Spot. We are able to supply a key and value pair to easily drill down into data. Hey, show me everything from this IP, show me everything from this user, and then allow you to slice and dice the data and drill down into it based on a number of pre-configured facets or widgets, whatever you want to call them. So we've got all the data from this IP address at the time of interest, right? It's already sliced and diced based on these facets that I've configured. So I can see that we had a number of users that were active on this system at the time of interest. If I click on Jay Smith here and start looking at what he or she was up to, I can see the events that they're associated with. If I look at this user, you'll notice that I'm getting these results very quickly. I'm not having to wait minutes and hours for my dashboard to be updated. So in this particular case, I can see that this user was browsing to CNN.com, USA Today, the Washington Post. I mean, they weren't working real hard at this time, but I don't see anything suspicious that was going on here. So I can kind of go on to the next user and see what was going on there. In this particular case, I can see that Jay Smith connected to 2 Russian domains, which may or may not be suspicious. But I talked about earlier how within the open data model, we've got the observation data, and then we've got other data, right? The user data, the endpoint data, the network data. So in this case, the network data, the who is information, is telling me that this event right here, the second one, they connected to a Russian domain that was registered a week before this connection took place. What our adversaries will do commonly is they'll register a new domain, they'll direct their command and control traffic to that domain for a very short period of time. They'll get their next set of instructions out to the systems that they own. That domain registration will expire, meaning that network doesn't exist anymore. They move on to another domain, right? They do this to hop around so they can't be tracked. So if leveraging that context, the network context here, we can definitely conclude that we have a system and user that was impacted by a threat on that 172.30.0.46 IP address that was first bubbled up through our machine learning. So let's pivot here and let's take a look at threats across the user dimension within the open data model. So what you're looking at here are the top user-based threats that have surfaced up through our analysis. If I look at this first event, you'll notice when I click on it, it updated the user profile here in the upper right-hand corner. If we're trying to evaluate events, User-based threats. You need to have the user context in order to do so. Right? Who is this person? What entitlements have they been granted? Right? What's their job title? Who's their boss? Right? If a DBA logs into an Oracle database as sysdba, privileged user, that's fine. But if our director of HR does that, that's not normal, right? So the importance of understanding the context of the user is critical here. And through the open data models, we're able to provide that user context right there at your fingertips. So in this case, we've got G. Brody. She accessed this malicious URL. We know it's malicious because our threat intelligence provider, Anomaly, told us so. So the open data models account for threat intelligence, right? And within Spot, we match our observation data against threat intelligence data so that we can surface up these types of threats. Same thing here. If I look at Jay Smith, we have his context, and we can see that he visited this malicious URL as well. Now, as an analyst, when I'm investigating one of these threats, the next question I'm gonna say is, hey, show me everything else Jay Smith did in the time frame of this event of interest. So, that's what we have here. This widget updated with all the other events from Jay Smith in the time of interest. Similarly, show me anybody else that connected to this same malicious URL. Did any other system or user connect to this website that we know is spreading malware? And in this case, we can see that Jay Smith and Watts B both connected to the same malicious URL. So we have two individuals, two systems that have been affected by the same threat. A couple other key points here. You'll notice that these threats, it's been prioritized by two privileged users. Obviously, our privileged users have the keys to the kingdom. They have, our HR director has access to all our employee records and sensitive information. Our domain administrators have access to, pretty much every Windows system in our network. Same thing with the DBAs. So we're actually using the context of the user themselves to prioritize the threats. So another good example there of how we're marrying up, the observation data with all these other references, to various entities. If I hover over one of these rows, you'll see, a number of other attributes that are available that I would use as an analyst. We obviously can't show 20, 30, 40 rows in the UI. It gets too cluttersome. So all the data is there, including the raw data, what we maintain in its full fidelity all the time. So if you look at the bottom here, you see an attribute called raw, and you can see the raw blue coat proxy event. That this is the source event that tripped this thing being identified as a threat. Within that proxy event, you can see that the URL that was connected to, ultimately that matched something that we knew was malicious. But you'll also see other context in here, right? So if you look at source IP4, source description, source OS, so these are attributes from the system that John Smith connected from. Right? Another example of how we're tying the endpoint data to the observation data to the user data so that you have all this context at your fingertips. So last but not least, let's pivot to the endpoint dimension, or the endpoint component of the open data model. So similarly to the last tab where we're looking at user-based threats, now we're looking at endpoint-based threats. And we have an endpoint profile where we're going to convey all the context that we understand about that endpoint. What I should have mentioned previously is, in most cases, your user data, your user context, most organizations are going to source that from Active Directory. It can be sourced from any type of user management system, whether that's an identity and access management system, some third-party, Active Directory equivalent that you may be using. The endpoint profile information can come from a couple different places. It can come from vulnerability scanners. It's going to tell us the operating system, which vulnerabilities that endpoint has, and so forth. A lot of organizations have their own IT asset management systems, essentially a database where they store what assets they have and the attributes about them. Regardless of what source you have, we're going to pull that data in, and we have a standard way of normalizing it, right? That's what the open data models do. They abstract the source data from the actual analytics, right? So that we can build upon a common structure and share analytics and so forth. Right. Similarly to the user tab, this time we're using context about the endpoint to prioritize the threats. And if I drill down on one of these events, you'll notice. Let's see here. Might have a little network connectivity issue. But anyway, you'll notice that these widgets will update. Those drill downs are pre-configured so that it's going to show me everything else from that endpoint over the time of interest or every other system that connected to that same malicious URL. So that's kind of what we had planned to show here in terms of the demo. At this point, we'd like to open it up to questions, anything we can help you better understand.
Yeah.
How to set the correlations for this? Can I set the correlations rules?
So the analytics that we provide with Spot out of the box are the machine learning for NetFlow, proxy, and DNS. That's the LDA model, the latent Dirichlet allocation. We provide threat intelligence matching. We provide the open data models and the predefined relationships amongst the observations and all the entities of information. And then the community is working to build additional machine learning models. For example, we're working on a model to analyze authentication events so that just focusing on authentication events, we can identify the ones that are most likely, malicious or indicative of a threat. From a rules perspective, the platform has the ability for us to input rules type of logic and alert us in near real time, but there's not a bunch of prepackaged rules that come with it, right? So that would need to be configured, but it's a capability of the platform itself.
Right. To add on to that, we want to let the SIM do what it does best. Right. The SIM does a good job identifying known threats. Rules engines make that possible. We can certainly talk about transforming some of that workload over to Hadoop, especially for identification of long-term analytics. So if we want to look at data over months or years, we're going to do that in Hadoop versus a SIM. But the rules engine itself, we're going to primarily leave in the SIM for now and offload the rest of the use cases that are more advanced, more CPU intensive or memory intensive into Hadoop. There was another question, yes, sir.
Yeah, I was wondering if you can provide any input on the data-centric cybersecurity. A lot of companies are thinking along those lines. Do you have any input to that?
For the data center cybersecurity, is that?
Data-centric cybersecurity.
Data-centric cybersecurity. So this is definitely one of the areas that I personally like to see us evolve into. Today we're focused on the network, the endpoint, the user, things like that. Certainly data is another huge component, right? And whether you call it data or artifacts, objects, there's many different names for it. And the idea is we want to be able to describe all that information, run analytics against it, run machine learning against it, look for what percentage of my PDFs that were downloaded versus sent an email had malware associated with it. Right? What percentage of my executables that came in from a download from a Java object have some sort of malicious logic attached to it. We want to be able to look at data in a whole nother way. So there is thought process into the open data models of how to start to account for that information. Today, it's primarily sourced through threat intelligence. The threat intelligence data model actually contains elements for how other people analyze that information and provide that back. So if I wanted to submit things to VirusTotal or any other sandbox, whether it's static or dynamic analysis, the output they provide could be used as comparison for the rest of everything in the system. And in the future, yeah, we could talk about, or even as a services engagement, we could talk about how to build analytics around the data that exists today. Yes, sir. Hang on one second.
How many data sources you use to come up with this analytics and from what systems?
So the machine learning is specific to DNS, proxy, and NetFlow. In terms of what's in here, just in our test environment, we've got snort events, we've got Windows operating system logs, we've got Blue Coat proxy, the three that we already talked about. There's probably 8 or 9 different sources.
And the idea there is, while the data source list isn't 600 long, building the open data models first means we can transform those easily, especially if they're already in a SIM system of some sort. Right? If they're already in a SIM and we can be written out to SAF or SIF, we can transform those into the open data model and work on ingest much faster. Or we can work with you on individual data sources that may be unique and put them into the open data model. So that as they change, your analytics don't have to change. Your analytics can stay the same. You can leverage that same application or that same process, even though your data may change. Hang on one second. This gentleman had a question.
Yeah, actually, my question is similar to his. It's my original question was like, what kind of raw data is what we needed, to do the analytics against it? Does it have a system log, audit log, and database log, and so this kind of information. So, but yeah, that's pretty much the same.
So, and we should probably repeat the questions now that I think about this. Sorry, guys. The question up here was very similar to the last one, which was, where do you start? What kind of data sources do you start with? There's lots of different kinds here. And my answer to that question is almost always, what are the use cases you want to solve for? Right? If we want to talk about, maturing your organization in detection for malware, there's a certain set of event sources that are going to benefit that. If we're looking for insider threat, there's a different set of data sources that are going to benefit those sorts of analytics. So it's working with your organization to understand what are those use cases, and then what's the underlying data sources that are going to benefit those analytics necessary to solve for that use case. Those are the ones that we'll prioritize to get in place. The default configuration, as we've described, though, is we'll solve for NetFlow, DNS, proxy analytics, general search and analytics across all data that's structured or unstructured, as long as we put it in the open data model. Yes, sir.
You had implied the port 119 or something like that was where you detected some unusual activities. Was this a rule put into the machine learning, or machine learning itself knows based on previous rules that this is a bad port or not a good?
But all the machine learning does is the LDA is a topic model, and it creates a model for each individual event and compares it to a baseline of activity, and then it calculates the probability for each event. So that one was the least probable event in our complete NetFlow data set, which is why it was surfaced.
Other questions? Yes, sir.
A little about the ambition of the product. Would you be able to life cycle an event you identify, assign it out to somebody, or how do you say it's resolved? I guess that wasn't part of the demo, but I'm just curious if that, where that hooks back in.
So the question is about workflow management, if I summarize it right. So how do I escalate to another analyst, or
you just close an issue if it,
or close it? So I'm going to answer it 2 ways. The first is, can you click on the network tab for a second? So the first way I'm going to answer this is everything that's being brought up in this network view is an output of the machine learning, right? So it's unsupervised machine learning. We're going to train that machine learning through supervised machine learning, right? We're going to do the supervised thing by clicking on it and ranking it up or down. Right, we're going to say, I want to see more events like this, or I don't want to see events like this, get rid of them. And we're going to train machine learning models to do that. So from a data science to security analyst workflow, where the data scientists have built the models, the analysts have the context, they're working together through the application to deliver that sort of workflow. In terms of escalation through resolution, right? I have this issue that's identified and I need to go make a change. This is where you would integrate with third-party tools, right? So if you wanted to integrate with an orchestration tool of some sort, to go push it off, you would work on an integration, and there's easy integration access to everything in Hadoop. No worries, I explained it. All right, any other questions in the back there? Everybody seems awake, that's good. All right, well, thank you guys. This is important for us to be able to get out this message to the community about what Cloudera is doing to support cyber security analytics to benefit the entire community, right? This is all available. You can download Apache Spot and start yourself. We're certainly willing to come help you get a leg up in this, help you build a cluster, secure a cluster, get you started with analytics, learn more about your use cases. Both of us are available for conversations on these topics if you want to learn about what other people are doing, how they're getting there, how they're starting. We're certainly willing to schedule WebExes or conversations with you to help you get there faster. And start to mature your organization's detection capability, having better visibility, having more analytics, and ultimately reducing the risk in the enterprise. That's it. Thank you all very much.
Appreciate your time.